Hello viewers, today's video is a bit different from my rest of the system design interview videos. In today's video, actually I have asked a friend of mine who is an ex-Microsoft and ex-Airbnb employee to actually take a mock interview, and he will be asking a system design interview question which he hasn't told me yet. So I haven't prepared for what he will be asking me, and so I will actually try to design this whole system at one time. So please consider this YouTube video as an example for how you have to tackle a system design interview, especially when the interviewer asks you something which you haven't prepared in advance. And you will see now in this video during the mock interview how I am thinking out loud, how I am going through all the different things, how I'm actually expressing my opinion with confidence, how I'm discussing different design approaches, why one is better than the other or not. And you will also see that even in the interview there are something which I don't personally like, but I did that. For example, the back of the envelope calculation, I don't personally prefer them, but since the interviewer asked me to actually perform the back of the envelope calculation, so instead of arguing with the interviewer, actually I did perform some back of the envelope calculation very quickly. So I hope that you will find this video useful. So let me know in the comments below if you find this video useful, and if you find it useful and valuable and you learn something about how to tackle a system design by going through this mock interview, then please also like this video. And if you haven't subscribed to my channel yet, then please subscribe to this channel and click the bell icon so that you get notified when I am uploading some new videos. Also, please note that I have not edited this mock interview video so that you will have the experience of real mock interview. So let's go and see the mock interview.
Hi, let's do a mock design interview, and I want you to design YouTube.
Okay, so before designing YouTube, I think we should first discuss what would be we should try to scope down the whole big system and see what are the different functional and non-functional requirements that YouTube have and that we would like to actually tackle in this interview. So let's see whether we have a text box or something. Yes. Okay, so let's see what are the different functional requirements that we can think of about the YouTube. So first of all, I think we would like user to actually have an account. Of course, user need a Gmail account in order to upload videos to YouTube. So user account. The second, I would say, the functional requirement is basically we would like user to upload a video. So upload video functionality. And in the same way, we would like, once the user has uploaded the video, he should be able to provide some metadata information about the video. For example, the title, the description, the tags, etc. So metadata information about the video. So this functionality is only related to the user who is actually a creator or who is a YouTube video creator. But let's now discuss the functionality and the requirements from the perspective of a user who's watching different YouTube videos. So the very first, I would say, functionality would be that user should be able to search some YouTube video. And of course, once the user finds the video, then the user should be able to play the video. And of course, all the different actions that the user can perform, like forwarding the video, move to a particular time in the video, etc. Apart from that, we would like also YouTube to actually recommend videos to the user. Recommend videos to the user. So in a user homepage, the user could see different videos recommended by the YouTube. At the same time, user should be able to subscribe to different channels in YouTube. And of course, this is all functionality related to user watching videos. And this is the functionality which is user creating or publishing videos. And of course, here we could also say that user should be able to create a YouTube channel. And in a channel, he can share different YouTubes. So I think these what do you think? I think we can actually keep all the functional and non-functional requirements for this interview. I think we can just keep these functional requirements.
They look good. Yeah.
Yeah. So now let's see what are the different non-functional requirements. That YouTube could have. So I think the very first requirement is always we want our system to be highly available. We don't want YouTube to go down, and we don't want user to actually see the message that the user is down. And we would like also our system to be fault tolerant. So even it's totally possible that some servers in YouTube may go down, but it will not actually affect the overall functionality or overall availability of the service. We also would like our service to be highly scalable. As the load on the users, as the number of users increase, as the number of videos increase, we also would like our system to be highly scalable. We would like our YouTube service to be durable. So once a video has been uploaded to YouTube, we don't want the video to be deleted, and we would like to keep that video in the system. Then as far as the consistency is concerned, the consistency requirements has I would say there will be different consistency requirements for different parts of YouTube. For example, when a user is uploading a video, then after uploading a video, he should be able to see that video, that he has uploaded that video. So we need a somewhat strong consistency there. But as far as when a user is searching a video, and let's say another user actually upload a video at that time, and that video does not appear in the search, it's totally fine. Because at that level, we can have some sort of eventual consistency. Similarly, when a user actually make a video public, at that time, it's totally possible that some users will see that the video is public and some may not see. But I think here also it would be okay to have eventual consistency where some users would see that the video is public a bit later. It's fine, I think, from the consistency requirement.
Yeah.
So I think these would be some functional and non-functional requirements. I would also say that, of course, when we are designing this YouTube service, we will have some monitoring service analytics, because as part of service development and also operations of service, we always need some monitoring and analytics as part of the service operations as well. So which will tell us the health of the service, the load on the service, etc. So which I'm just discussing here right now, but of course we are not going to, if you want, we can go into that detail as well, but I think right now I will keep focus on these functionality, non-functional and functional requirements. Okay. What do you think?
I think that's the right approach. We can discuss monitoring later if we have time.
Okay, cool. So usually I know that there are people who actually prefer some back of the envelope estimation, but usually I don't want to waste time usually in estimating the back of the envelope in doing this back of the envelope calculation, because I think that we should try to actually first try to design the service based on the functional and non-functional requirements, and try to keep the design as flexible enough so that if it needs to be highly scalable and available, we can make so. And as far as the estimation is concerned, we can actually, of course, we can go and like waste 5-10 minutes doing that. But eventually, I think at the end, I think what we would need is basically just to know, okay, what are, if let's say if you're uploading videos, what would be the size of the video, how much storage we would require. And of course, these would be estimations, and we will have analytics and monitoring service to actually keep an eye on all those metrics. And that's why we can start with some initial storage, and we can always increase that. That's why I don't want to waste time on that. But if you would like, I can go into back of the envelope estimation as well. Otherwise,
So
we can go to the, directly to the high level design and then the detailed design.
So is the estimation is useless? Like doing the cost estimation is really never helpful, or it is going to be useful at some point later?
I mean, it's usually useful when you are designing your service in real life. It would be a bit useful because we would like to know what would be at the beginning, what would be the scale could have, or there would be of course, it will be just an estimation. And the real numbers might be different, but it will actually make you decide, okay, do I need to allocate, let's say, 3 app servers or 6 app servers or 10 app servers for my service based on the load that I'm predicting that will happen from day one. Because
Okay.
as far as the adding new servers are concerned, we can always add new servers if we see that the load is increasing. And we can always start with some bare minimum number of servers that we really need in order to design the service.
Okay. Let's do some 5 minutes cost estimation, some estimation of numbers so that we have some data available.
Okay, let's do some cost estimation. So let's just assume that right now, I don't know right now what would be the the current, I think how many users YouTube has, maybe almost, I would say almost a billion users. But as far as the users who are uploading the videos, I'm not sure how many of them are right now. Let's consider them maybe, I would say 100 million. Let's say if there are 100 million users who are actually publishing videos.
Okay.
And let's suppose if they are actually publishing video, on average, I would say every week, like one user is uploading video once a week, for example, once a week, video upload. And let's say in that case, a video on average, usually, well, nowadays you will find videos from like under a minute to more than like hours, like 6, 7, even 8 hours of videos you will find on YouTube. But let's just assume right now that on average, there will be video for around 15 to 20 minutes. Let's say 20-minute video on average. There will be videos which will be, of course, less than 20 minutes, and there will be videos which will be more than 20 minutes. But let's just assume these are on average, there will be a video of size 20 minutes. And of course, it will be using, let's say, 1080p. And usually when YouTube uploads, when you upload a video on YouTube actually saves those videos in multiple different bit rates and different formats. So for example, if you upload a video at 1080p, usually YouTube usually store those videos not just in as 1080p, but also as 720p and 480p and 320p, etc. Because we will discuss later also that YouTube actually uses adaptive bit streaming to actually make the experience of user to be like, to make the user experience good. Actually, this is also, I think, one of the non-functional requirement that we didn't discuss, that we would like the experience of user to be like fast. We would like video playback to be faster. So it means that the server would be actually able to recognize the client. So the client will inform the server about its bit rate that it has, and also the screen size, etc. And the server can actually send the right size video to the client. So apart from that, I think, so let's say if we are doing a 20-minute average 1080p video. So usually, as I said, there are videos like usually 20-minute video, depending on the bit rate, could take around on average 10 to 20 GB. and if it's a very high quality video. And so let's say on average, we say it's 10 GB video. And of course, YouTube actually also store this video in other different formats as well. Like if you're uploading a 1080p, YouTube actually also store the other formats of the video, like which have reduced resolution, like 780p, etc. So usually I would say on average 10 GB for that, around 5 to 4 GB for 720p, around 1 GB for, I would say, let's say 480p videos. So usually I would say on average, let's just say that there will be around 15 to 20 GB per video of storage that we will have for a video.
Mm-hmm.
And now depending on, let's say 100 million videos per week. So you can say 100 multiplied by almost, let's say 20 GB, which is almost 2 terabytes of video per week that would be uploading. And in that, and based on that, we can see how many videos we would see, let's say in a month or in a year, for example. Do you want to go further into that, or should we go to the high level?
Yeah, I think this is good enough. We can move to the next section.
Okay. So let me draw the high level diagram. I think, is there a way to make it bigger? Okay. So I am actually going to draw the high level diagram of the. So there are multiple parts. If you see from the user's perspective, the YouTube service will be actually comprised of multiple microservices. There will be an upload service. This upload service will be responsible for uploading a YouTube video. And we will go further into it and see how those upload service, what is the functionality of the upload service, how it works, etc. Apart from that, there will be, of course, let me copy. There will be a user service. There will be, of course, I would say a channel service. A user can have multiple channels. So there's a channel service, which actually will store all the information about the channel the user has. Apart from user service and these channel service, there will be also other service, which is like, let's say, search service. There will be recommendation service. So these will be different services that we will see in our system. And if you want, we can actually go in the design of these services one by one, that how these services will work together.
Yeah, let's go.
So usually what happens is that when we actually upload a service, so we will go and see how the upload service works, and then we will see from onward that usually, let me actually draw arrows. So once the service is, once a video is uploaded, that actually information goes to the channel service as well. Also, the same information actually goes to the search service, because now once the video is uploaded, then once the video is uploaded, the video is searchable, and of course the same video can be recommended to other users also. So this is which it also goes to recommendation service, and we will see the design of all those things when, like, how these are implemented.
Okay.
So if you like, we can first go and see the design of upload service.
Yeah.
Okay. sorry. So usually upload service, if you check, it will be comprised of multiple app servers. So there will be at least 3 or more app servers here. I'm just going to draw right now 2 app servers, but there will be multiple, and they will be behind a load balancer. So they will be behind a load balancer actually. Apart from this, there will be actually a object storage service where the video will be uploaded. So it's like S3, for example, if you are using. And in the same way, we will also have some distributed cache as well. So let me see whether I can draw a distributed cache, if there are suitable shape for it. Let's see right now. Let's just say this one is a distributed cache. So usually what happens that when the user is uploading a video, that video will be, of course, at the client side, the client app, or in that case, in the browser, for example, when you open the YouTube Studio, inside the YouTube Studio, when you upload a video, the video actually gets uploaded to the object storage. So usually what happens is that if you have done this, you will see that once you start uploading the video, you will see a message on your browser that please do not close this browser tab, because you don't want to actually disconnect the connection that your browser has with this app server. And usually what happens that even in between, if the connection drops, the browser then makes request to another like connection, and that connection can go to any other app server also. So what happens right now, once the connection is established from the user browser, let me draw it also here. This is the user browser. You will be actually sending you will be uploading the video in the form of course, small packets or segments that will be uploaded to the object storage. And once the storage is done, the app server, any point of time, will actually send, at that point when it's done, it actually sends a message into this queue. This is a distributed queue. It will insert the message in this distributed queue, informing about the video that has been uploaded into the storage. And now they are into the storage, and now there are multiple agents that are listening to this queue. And what they do, they actually post-process this video. And what those agents done, that whenever they find any message in the queue for any video that has been uploaded, then they go to that video. They actually break that video into different small segments, and they do the process of transcoding. So transcoding is basically what is that usually, if you go into the detail, you will understand that usually when you upload the video, you upload in some format. It might be MP4, it might be some other video format. And usually if it's MP4, it's some sort of, I would say, compressed video format. So in the process of transcoding, they first actually decompress the video to get the raw video, and then they actually encode the video again into another compressed format. And of course, as I told you, that whenever we upload a video on YouTube not just, let's say you're uploading a video of bitrate, let's say 1080p. YouTube not only store that video, but it also actually post-process this video after the upload, and actually also store other formats of this video with lesser bitrate as well, like 720p, etc. And also it also depending on not just the bitrate, but also this is because this is actually the I would say it's important later on, because now what happens is later on the client that is trying to access the video could be either a desktop or could be a smartphone or mobile phone. And in that case, the client could have different sizes, or the client could support different sizes. And that's why YouTube also, after the user upload the video, it actually post process that video and do this transcoding from the original format that the user has uploaded to into different other formats. So what happens now, these app servers, these are the upload servers. And once they upload the video into Optic Storage, they will insert a message in the queue. And then there will be agents that will be listening to that queue. There will be multiple agents. And those agents, what they do, then they actually do the transcoding on that video. And they also at the same time divide that video into different small segments. And usually these segment size are from, I would say, 3 to 10 seconds. And then they store them in the object storage again in those small chunks. So this will be the upload service would look like.
What is the need? What is the need to make them in small chunks? To hide them in small chunks?
Okay, yeah, I can tell you about this. So this is a concept. This is something which is called adaptive bit rate, or adaptive bit streaming. So let me actually adaptive bit streaming. So let me give you an example what happens in the adaptive bit streaming. Let's suppose we have a video and it has different, let's say, segments. Let's say segment A, B, C, let's say. This is in 1080p. The same, basically, the video gets also, the same segments also stored as, let's say, a lesser resolution, which is, let's say, 720p. So these ones, the upper one are like, these are the 1080p, these are the 720p. And then also there will be another one for 480p. Now, usually what happens is that, let's say a client comes. Let's suppose that there's a client. I'm just going to, this is a client machine. And the client, initially, when it start downloading the video, it tells, okay, I'm at a very good network connection and it's a laptop. So it start copying this one. This is the one which is basically, let me copy. Okay. So this is 1080p. This is 720p. This is 480p. So the client start downloading this chunk A or segment A and start playing. And while it's doing that, it's realized that its network speed is not that good. So in that case, what happens that it can always actually switch from downloading this B to this B.
Okay.
Because what happens now, because let's suppose if the client connection is slow, then after playing this segment A, if this segment B is being downloaded and it's not yet downloaded, then what will happen? The video will get stuck at a place and you will see a hourglass. Yeah. And this is a bad experience for the user. And that's why that's why what YouTube does is that it uses the adaptive bit streaming, where and this actually works between the server and the client both. They both work together in that case. And the client from time to time actually checks how much segments it has downloaded and what is the current network speed that it is seeing. And
Okay.
based on that, it can actually tell server that, okay, I don't want this B segment at 1080p. I can actually I can take the one from 720p because my connection speed is not that good.
Yeah, that's good. So let's move back to the upload design. Is everything complete there, or there is anything else needed in upload service? So
So I think
you said there are multiple agents pulling these events from queue. Is this all
yes.
agents the same kind, or there are different kind of agents doing some other stuff as well?
So now it depends what are the, let me see, these are the different agents. So these agents which are here in this video, there are multiple types of them. First of them is basically the ones which are doing the transcoding. So there will be transcoding agents which are doing transcoding. Apart from that, there will be other agents also which will be actually once I think this is where this transcoding agents, they will be what they will be doing. They will be actually breaking this video into different segments and then putting them again in the queue so that they can be further processed. So let's say an agent will actually break this a video. Let's say it's a big video, and it will break it into, let's say it's into different like 100 or 1,000 segments, but depending on whatever the size of the video was, and it will actually upload those segments into the S3 or block or object storage, and it will also insert notification in the queue, and then there will be other agents which will then receive those those messages from the queue, and based on those, they will actually start transcoding each segment in individually.
Okay.
So in this case, what will happen that multiple agents would be transcoding different segments of a video in parallel.
Okay.
Sounds so that good. Would be one thing. And so once all of them have, and that's why you will see usually when you upload a video, it takes some time to post process. It depends on the number of agents that are currently working on right now. And of course, there will be multiple users who will be uploading their videos. So it could all depends on the load factor. And of course, if we see that the number of that the load is increasing, we can always introduce more agents, because these agents are nothing but just stateless host or like components which just get data from the queue and perform the transcoding on the segment and then upload the segment into the S3 again.
Sounds
so
good.
This will be one thing. Apart from then, once they have completed the transcoding at that time, what we can do, we can also inform these agents can also inform the channel service. So where they will say, okay, now this video has been uploaded and it's now available. Like usually when you upload the video, when you start uploading video, there will be a message that will be sent to the channel service. And so you will see that, okay, now you will see that there's a video that is getting uploaded, and you can actually go and update all the metadata information for that video in the channel service. But still, you won't be do anything else, because right now, as far as the video is concerned, you will see that the video is still being uploaded. But once the agents have, once the video has been uploaded, and then all the transcoding agents are done with transcoding of all the segments of the video, at that time they can notify the channel service that, okay, now this video is now ready to be shared. Okay. So they can, at the end, they can actually send the message to the channel service again.
So let's talk about search service. How is search service will interact with videos, or how it will index?
Okay, yeah, we can go into that design now. So how much time we have now? 9:44. Okay.
We have 10 minutes.
We have 10 minutes. Okay. Let me try to then quickly. Let me just. So usually, as far as the search service is concerned, we can actually divide the search service into, I would say, two parts. The first part is basically the part which actually generate these search index for the video. So what happens is that once the video is uploaded and then the message passed to the search service that is a new video available. And usually this is the case when the video is made public. If the video is kept private, of course, there's no point sending it to the search service because the video is private. But once the video is made available, it's made public, at that point, this will be the channel service where you will make the video public. And the channel service will notify the search service that a video has been made public now. And at that time, what happens, there will be in the search service, there will be two part of it. Let me search indexer, and the other part would be, I would say, so the search indexer is the one which is responsible for creating the inverted index for the video. I will let you know what is the inverted index is, but there will be like search indexer, and then I would say let's give it a name, search finder, for example, where this is the service or microservice that will be serving the user search request. So usually what happens now, the channel service actually notify the search indexer service. The search indexer service will be, again, different app servers behind load balancer. And what it will do, it will provide some information about the YouTube video. Those information will contain the description, the title, and the keywords that the user has specified while uploading the YouTube video. And now what this search indexer service will do, first of all, it will actually try to actually figure out what are the different, so it has all the first tags which the user has specified. These are the keywords already. It will also go through the description and the title to get the tags or the keywords that it can create, for which it can create the search. So these are the keywords or the search terms for which the search indexer service will generate the inverted search index in that case. So what happens now, let's say we have a video, let's say YouTube video A that was passed to it. The search indexer will actually go through the description and the title and it will create these terms. And now it will actually store these information in an inverted index. And how the inverted index look like? Let me give you an example. So this information we can actually store in, let's say, in some data store. And that data store will be partitioned. There are now two ways we have to actually partition the data store. For example, we actually can partition the data store based on the document itself or the YouTube video itself. So in that case, what will happen? All the search keywords, there will be an index on the search keywords for that YouTube video that will be stored in the same, let's say, partition. Let me copy it. This is a data store. In the data store, we have, let's say, we have a table, let's say a video table. And what this video table has, if you go and check this table, the video table has, let's say, a video ID, and then of course it has other information like title, path to the video, for example, etc., and then keywords. And so this is now, it depends whether we shard this. This data store will be sharded by the, let's say, video ID. And what happens now, that when this search indexer will create an index for a video, these keywords, these are basically, they have a secondary index on these keywords as well. There will be secondary index on these keywords. the video ID is the primary key. And now we have two approaches to actually store these secondary indexes. The first approach is that we always store all the, like, there are two, so that the partition where the video data is stored, we also stored all the keywords or the terms for that video in that partition. So let's say there was a YouTube video about designing YouTube. So it has keyword like designing YouTube, and that keyword, which is a secondary index, will be stored here in the same partition where the video is stored. And now in that case, what happens that whenever a search needs to be done, let's say a user is searching for designing YouTube, then the search finder will actually send the search query, and it will scan all the different partitions for all the videos which have this keyword designing YouTube in it. So in this case, the queries will, the search finder will send, the search will actually scan all the partitions in parallel. This is one approach. The other approach we have is basically that we have these secondary indexes. So the first approach that we already discussed is called a local index, where the indexes are stored locally. There's another approach, is a global index, where we partition the data store also by these keywords or terms as well. So for example, designing YouTube is, if it's a term, it will be stored in one partition. And so all the information about all the videos which have this keyword designing YouTube will be stored in one partition only. So in that case, what happens is that when the search index, there are different pros and cons in both these approaches. In the first approach, the search indexer only writes to a single partition, both the information about the video and its keywords on which we can perform the search on it. And then the search finder actually scan all the partitions when searching for some term. And in the second approach, the search indexer will actually write for each keyword, it will go to a partition of that keyword or term and will write information about the video there. So in that case, the write will be a bit slower, but as far as the search is concerned, search will actually, based on the keyword, it will just go to the single partition and read the data from there.
So what is the scheme for first partition? What are you choosing to partition in the first strategy? You're using the video ID or title? How are you partitioning that data?
So that's what actually we do. In the inverted case, that's what I'm saying. What will be happening is that if we are actually, this is, as I said, this is an inverted search index. Mm-hmm. And inverted search index means that there are some terms. There are some terms or keywords to a video ID. We need that. Mm-hmm. So in the first approach, we were partitioning everything by video ID.
Okay.
So that's why it's totally possible. Some videos are stored in one partition and other videos are stored in other partition. And when a video A is stored in one partition, all the terms which that video has, they also get stored in the same partition or in the same machine in that case, for example.
Yeah.
Okay. That is the first approach. And that's why the write is way faster, but the searching is slower, because in that means if a user is searching for a video designing YouTube, then you have to search all the different partitions. You have to send the search query to all the partitions, and then all the partitions which have this, which have any video with the term design YouTube will actually return you the results.
Okay.
Of course, then you can perform the ranking.
So which strategy should we use, first or second?
First or second. So I think as far as the rights are concerned, so there are other issues as well. First of all, let's say if we use the second approach where the search terms are written to one partition, then it's totally possible that there could be some search terms which are hot search terms. So there are a lot of videos that are associated with those search terms.
Mm-hmm.
In that case, that partition will become very hot.
Yeah.
And it also depends, like also if there are a lot of people are searching for something.
Yeah.
Also the same partition will become very hot in that case. So that's why I would say, we have to decide, of course, on one approach. And usually in that case, easiest would be, I would say, that we start with the first approach, because it will avoid any hot term issue, like where a search term becomes so hot that everyone is searching, and so we are hitting a same partition all the time.
Mm-hmm.
We will avoid those type of scenarios if we use the first approach. And of course, in that case, what will happen? That the scan query can take a lot of time, but now what the search finder can do, the search finder will have some aggregate servers, which actually where the users actually query them, and then they actually initiate the search query. And it's totally possible what these aggregate servers can do, that it might possible when they initiate the search, and some partitions may return the results early and some may not return early. So as soon as they have enough results, they can actually rank those results and present them to the user.
Okay.
So they don't have to wait for all the results from all the different partitions to come up.
All right. So we are running out of time. So to wrap it now. So thank you very much. It was great learning from you, doing interview with you, and I learned a lot while doing this interview. Thank you.
Okay, thanks. So guys, this was the mock interview.
I hope you must have found it very useful and valuable for you. This mock interview video was not edited. We didn't edit anything in this mock interview video so that you can have the real experience of how an interview look like. So let me know in the comments below if you find this video useful, and if you have any other comments, if you want me to make videos on any other topic, then please let me know in the comments below as well. Thank you and take care.